Okay, we're going to work on solving an area problem using cross product. So we had just spoken about force. We're going to focus on, in this question specifically, determine the area of a parallelogram determined by these two vectors. Okay, and we'll put a visual along with it. Now the area of a parallelogram with sides vector A and B is equal to the magnitude of A cross B. Okay, so essentially if we find the cross product of the two, we would end up with a new vector value. And then we need to find the magnitude of that vector value, which would be equal to the area of a parallelogram. Okay, that same idea can be used with a triangle. If we can find our two vectors, do the exact same process, and then divide by 2. Okay, so in this question we have a parallelogram. So what's going to happen is this parallelogram is going to roughly look something like this in 3 space. We have two vectors. Okay, and no matter how you see this in 3 space, essentially these vectors create a parallelogram. So we're going to be looking for the area within these two vectors. Oops, wrong button. So the value we're going to find will be equal to the area enclosed by these two vectors. Okay, so like we said, the very first thing to do is to find the cross product of the two. Our formula being A2 B3 minus B2 A3 for x. For y, we have A3 B1 minus B3 A1. And for z, we have A1 B2 minus B1 A2. Does that look right? I believe we got it. We'll call this guy A1, A2, A3, B1, B2, and B3. We'll plug our values in to find our new cross product vector. So A2 was 5. So we have 5 multiplied by B3, which is -1. Subtract B2, which is 3, times A3, which is 6. That will give us a value for x. A3, which is 6, times B1, which is 2. Subtract B3, which is -1, times A1, which is -1. Will give us our values for y. And for z, A1, which is -1, times B2, which is 3. Subtract B1, which is 2, times A2, which is 5. And that should give us our new vector projections, which will be -5 minus 18, 12 minus 1, and -3 minus 10. So our new perpendicular vector should be -23, 11, and -13. So that's the cross product of our two, since we renamed them A cross B. But remember, in order to find the area of it, we have to find the magnitude. And we know we can find the magnitude of any vector by just doing the dot product by itself, right? If I want to find this, we'll call this new vector, we'll say vector C is equal to A cross B. Okay, we've renamed him C. So to find the magnitude of vector C squared, okay, we're just going to square each of these values. We've done this in several questions before. So 23 squared plus 11 squared plus -13 squared. This will give us 121 and 169, I believe. Don't know what 23 is. Squared. 529. 529. And we're going to add these values together, and then we'll have to find the root of them in order to find the magnitude of C. So 529 plus 121 plus 169 is 819 square rooted 28. 819. So the magnitude of C is not exactly 28. Did it round? 28.6, let's say. 28.6. Okay. So the area of this parallelogram is 28.6 units. Okay. Yes, if you're going to talk about 2 dimensions, you could say units squared.